Everybody, let's get started. This tutorial is FHIR profiling, an overview and introduction. So if you came for a different topic, now's the time to switch rooms, and if not, we're going to get started. I have a lot of information to cover. I actually have 60 slides in 40 minutes, and I'm planning to do them all. So I'm going to go really quickly, and you don't get to ask questions. However, after this session, we will have a hands-on session in the big room. And then you're all welcome to join me, and then you get to talk to me, ask some questions, go into depth about specific stuff that we deal in this presentation. Right? So let's get started. First, a little introduction. My name is Michel Rutten. I work for FHIR. Apparently, I have a yellow shirt. So, well, this is the computer that I wrote my first code on. It's really nice that Philips now is part of this community. That, for me, kind of closes the circle. For me, this is where it all started. And a couple of years ago, I specialized in healthcare. Started working with FHIR about 4 years ago, and I specialize in FHIR profiling, hence why I give this tutorial. And I'm the creator of Forge, that's a FHIR profile editor. So some of the topics I want to discuss: why do we need profiling? First, a little motivation, why are we actually here? I'm going to show an overview of the conformance layer and the different resources that FHIR provides that have to do with profiling. We're going to look at profiles themselves and extensions, how can you add elements. I want to talk a little bit about packages and new development within profiling. That has to do with version management. Implementation guides, and finally the registry, if I have sufficient time. So why do we need profiling? Well, FHIR provides a platform specification. FHIR tried to standardize a lot of these building blocks as patient and condition observation, but on a global scale. And you can't standardize everything because healthcare differs. So there is a way that we need to describe these changes, and that's why we need profiling. It requires a further adaptation to concept of use. So you adapt the patient to your local rules and add extra constraints. That's why we need profiling. So which resources do I use in my use case? I only need patient observation, for example, and I only need a specific set of elements. I don't do patient.animal because I'm not a veterinarian, for example. Which API features? I need to search on a patient, but I don't need to send you patients, for example, so I only need a limited set of operations. What terminology am I using? Do I require LOIM or SNOMED or ICD? And how do I map these profiles to local requirements? These are all part of a profile. And then we want to author them in a structured way. So this is a recurring theme in this whole conformance layer. Everything is structured. We want to make sure that we can reason about these profiles you make. You could do that as a Word document, but then only a human can understand that. And FHIR tries to express everything in a structured way. So we can write code. And we can do stuff like validate data that's been exchanged across the wire. We can generate code, we can generate a report, we can generate an input form, etc., etc. And that's all possible because it's authored in a structured way and not in a narrative. So this is key. And independent of the serialization format. FHIR allows you to use XML or JSON. Now Google is introducing protobuf, there's RDF, there might be new formats in the future. Profiling is on a conceptual defined on a conceptual level. So it's independent of the serialization format. Pick your favorite. So the conformance layer. FHIR provides, well, what is it, about 120 resources now in release 4, and there's a subset of these resources that are specifically designed for profiling. Those are infrastructural resources, they're not clinical. And you have a couple of subgroups. If you go to the Hl7 spec, you go to the resource page, you will see these categories, and that's where I made this picture of. So we have some terminology, value set being the key. That's where you define your terminologies, and you can bind them to an element, saying you have to use this code on this element. Structure definition, that's how you define resources, how you constrain resources, how you define an extension definition. It's actually a list of element definitions. You have a resource that allows you to define mappings, again, in a structured way. You can define operations, read a patient, search a patient, send me an observation, what kind of parameters. You can define searches. I support search patient by last name, for example. And there's some miscellaneous resources. You have capability statement. That's how a server advertises, this is what I support, this is what I don't support, again in a structured way. You have test script resources. The Aegis guys build a whole system around it. That's how you programmatically test your implementation. And there's even an implementation guide resource, so you can do that in a structured way. The core of all these resources is structure definition itself. This is actually, using structure definition, FHIR defines its own data types. Human name, address, string, all the data types that FHIR provide out of the box are defined by means of a structure definition. It also defines the core resources. So a structure definition defines how does the patient resource look, and how does the condition resource look, and even how does the structure definition resource look. So FHIR is built upon itself, right? These are the out-of-the-box data types that you get from FHIR, and then you can start constraining them. And again, you do that by means of a structure definition. So you can take the standard patient and add some extra constraints. And how do you do that? By means of a structure definition. Extension, you need to add some elements to your own profile. Again, you express it by means of a structure definition. And finally, we have a use case called a logical model, and that's where you define a set of elements that are not related to a FHIR resource at all. That's more on a logical model, and then you have to map it to a FHIR resource. So that's higher up in the abstract chain. So structure definition has a lot of different applications. So what can you use it for? Well, publish your profiles. You want some vendor to implement that interface, so you probably want to share the profile and then invite some vendors to do an estimate or give you a quote. You can compare them. Again, they're structured, so you can write code to look at two profiles and give you the changes. This is what the FHIR spec does, and it allows you to see the changes between release 4 and release 3. You can use it to transform data. You can use it to validate the resource. If you have some constraints on a patient and somebody sends you patient data, you can use that profile to actually verify that they conform to the constraints. Generate code, generate a UI. This is actually done by the FHIR build itself. And for example, a Clinifier is a profiling tool made by David, and he dynamically generates input forms driven by a structure definition. And all of this is possible because it's structured. If it was a Word document, we couldn't do all of this. Computable. So then, structure definition have a couple of related conformance resources. I mentioned operation definition. This is how you define your server operations. I for example, support a read on a patient, or a put on a condition, or an update on an observation. These are the parameters. You need to send me the patient ID, for example, so I can identify it, and I will return you the patient. And you can describe that in a programmatic way. And you can add your own operations. You might need to implement a complex document manipulation, or maybe a financial transaction that's not part of the standard. You can define your own and advertise those capabilities. Computable, again, and the same with search parameters. You can say my server supports search patient by last name, or search observations by SNOMED code. And you can, again, you can implement your own search parameters. I'm the server that my colleague Christian, wave your hands. Christian made a very nice piece of software where you can actually send a search parameter to our server, and it dynamically builds an index, and then 2 minutes later you can start searching on it without rebooting the thing or writing code. How is that possible? Again, it's computable. So we can write code that reasons about it and builds an index dynamically. And then finally, this all comes together in a capability statement. So when you have a client that hits a server, first thing you do, you ask, are you a FHIR server? Yeah, then what are your capabilities? Because I'm a client, I need access to patient data. Do you even have patient data on that server? So a capability statement describes all of this. Which resources do I support, which operations, which search parameters. There's just one requirement on a FHIR server. It has to provide a capability statement. So the trivial FHIR server is you put up a static page with a capability statement that's empty, saying, I'm a FHIR server, I can't do anything. You passed. And again, it's computable. So a client can, for example, dynamically enable buttons depending on the capabilities that the server supports. If you have a client that can connect to different EHRs, you could enable that search button depending on if the capability says, I support search. So, and your server might even not support all the formats. Say, we only do JSON, we don't care about XML, so I don't support that format, don't send it to me. And the Google guys say, we'll add a format to say, we support protobuf, because that's what we need to send in the AI. Security servers, your operations, your server parameters, resource, and also profiles. You can say, this server only accepts not generic patients, but only Dutch patients that conform to the Dutch MedMay patient profile. So you constrain it down, and you advertise these constraints by means of a capability statement. Finally, we have an implementation guide resource. This is a little bit less part of the core. You can write an implementation guide by just using Word or a text editor and put some images inside and then put that up, or maybe create a website. However, it turns out that sometimes when you already have a lot of FHIR infrastructure, it makes sense to use that FHIR infrastructure because your implementation guide creates profiles, you want to validate them, you want to make sure that your implementation guide is actually syntactically correct. So if you do it in a structured way, you can validate your implementation guide, so there's actually a resource that helps you with it. This is not mandatory. All the other ones I mentioned, they're key, you have to use them, and when you build a server, you probably will use them, or when you implement a use case. This kind of depends. You have to look at it if you need it, and if it makes sense for you to address this in a structured way. If not, just create a website. But again, if you need this, it's computable. So here you can see there's a little picture I pulled up from the website. You can find it on the spec. And this is how they all tie together. So an implementation guide tells you how do you build this interface for this specific vendor, and it will walk into all these different resources. A capability statement, well, it advertises the capabilities of a server, and again, it does that by advertising all these different resources. So to say, well, I support these profiles and these operations and these searches. Compartment definition, I don't even have time to go into that. But you can see how they're tied together. And especially these, this is the core of the conformance module. So as I mentioned, FHIR is built upon itself. FHIR is defined by means of a structure definition. There's a nice bootstrapping here. I don't know if you're familiar with the Baron from Münchhausen, but FHIR, you know, it pulls itself from the swamp on its own bootstraps. Or in another way, we eat our own dog food. We have been building FHIR using FHIR, and that's how we discovered errors or oversights in FHIR in the first release. And that's why we went through these cycles, to DSU2, SU3, and now to release 4. And a lot of the issues in the original design were discovered because FHIR is built using FHIR. So that was a tremendous value. A little bit about identification. In FHIR, all resources have an ID, a unique ID. But in conformance resources, we also have another unique identifier called the canonical URL, and there's a subtle difference. If I send a resource to a server, usually the server will assign the ID. It's out of my control. If I send the same patient to 5 servers, we'll have 5 copies of that patient data with 5 different IDs to keep them apart. Well, they're copies of the same patient, but they live in different locations. For these conformance resources, it's critical that we can see that they're all the same, that they're just copies of an instance. And that's why these conformance resources also have something like a canonical URL. And if you publish a profile onto 10 different servers, you can still see on the canonical URL that we're all talking about the same profile. The IDs will be different, like these quadruplets here, these babies. But when you want to address number 2, you use a canonical link. So this is crucial, and that allows you to create copies of these profiles on your own machine, and the whole infrastructure will still work because it tries to fetch a profile by means of this canonical URL, and not by means of the specific server ID, which is even out of your control because the server assigns it, so you don't even know what it's going to assign. The canonical URL, that's author assigned, you assign it. And it's up to you to make sure that it's unique, so it's always encouraged that to take your company domain, a domain that's in your control. So Hl7 uses hl7.org, you will use your company domain, and then, for example, in a registry, we can protect that and make sure that nobody else can publish on that domain. And this is how we can ensure that these canonical URLs are actually unique. One more subtlety, I'm talking about URL, but think URI. In the spec, you often see the term URL, but the only thing that for FHIR is really crucial is the I. It's a uniform resource identifier. It's not crucial for FHIR that it's actually there's a web page somewhere that you can hit, that you can put that URL in your browser and go there and it serves something up. It is very convenient though, so it's strongly recommended that you do, because developers, they will hit URLs in the browser, and it's very nice if you find a documentation page that describes that resource. This is what the FHIR spec itself does, but it's not mandatory. Nothing breaks in FHIR if there is no page and it just gives you a 404. What's crucial is that it's unique. Don't assign the same canonical URL to 2 different profiles. Don't do that. So again, if I post the same patient profile to 3 servers across the world, the servers will assign some unique ID, but they will all have the same canonical URL, my Acme patient, that I assigned. So, some more details about profiles. So what is a profile? Well, you can define constraints on a core data type. For example, create a custom address. You can define constraints on a core resource. Say, I'm going to constrain patient. Or you can constrain an existing profile. So maybe we have a Dutch patient profile defined by Hl7 Holland, but within my organization, I'm going to further constrain that down and saying, well, I don't support the animal element, for example, because I'm not a vet, again. So you can have layers of profiles, starting with core resource, moving down maybe to a national level, to a regional level, to an organizational level, and you can keep adding constraints. Trick question, what's the difference between a resource and a data type? Come on, don't have all day, raise your hands. Nobody? Yeah, close, close. So you can send a resource to a server, it will store it for you, and it will sign an ID, and that's how you can get it back. You can never send a data type to a server. You can't send a string to a server and expect it to store it. So data types only exist within resources. And you always exchange resources. You never exchange data types. That's the difference. In all other means and aspects, they're completely the same. There's just a list of elements. They can be complex, they can have nested elements, they can have data types, that's all the same. But the exchange between servers is always on the level of a resource, and never on a... I can't just send you a string, you don't even know what it means. But when I send you a patient.name, then you know what it means, so that makes sense. The term is overloaded, and especially when you talk to people coming from the V2 or the V3 world, they will use the term profile sometimes for something we call an implementation guide in FHIR. So just a little warning, when you're talking to people in healthcare IT, and you're talking about the term profile, just take care that this term is overloaded. And maybe you have to ask a little question with your partner, like how do you define a profile? So a very narrow definition, as I use it, is constraints on a resource or constraints on a profile. But some people will use it in a broader sense, and they actually mean a set of profiles with value sets, and so a whole implementation guide. Sometimes they refer to it as a template from V2, but sometimes you will also find the term profile. When FHIR, we try to constrain it to this meaning, but just take care. I mentioned the layering of profiles, a little diagram to make it a little bit more clear. So the out-of-the-box profiles that FHIR defines, they don't provide a lot of constraints. They're very flexible, all the elements are optional, and then when you move down the stack to national profiles, regional profiles, they will start adding constraints. So these profiles will get bigger and bigger and bigger and more specific. On the other hand, you have to set all of the FHIR resources over the world, and the number of resources that actually comply to the profile, that scopes down. It's in a way, for me, it's like a where clause of a SQL query. Once you start adding clauses to that where clause, you will get less and less and less rows back from the database. And you can even create a profile that will never match any resource. Like I can create a SQL query saying, select star where 1 equals 0. It's a valid query, and it will always return 0 results. So I can create some complicated profile with a slicing rule that's actually impossible to match. It is a valid profile, but you're just wasting your time. There's a nuance. So the more constraints you add, the less profiles will match. So what is part of a structure definition? Well, first of all, there's a set of metadata. As I mentioned, the canonical URL, this is crucial. That's how you identify that specific profile. It has a name, a title, a status. So you could say, when you publish it online, you can use it to say, well, we're still working on this and still changing. And once it's active, then you say to people, now you can start using it. There's some author information, contact information. There's also something like a jurisdiction. Say this profile is only for Holland, or only for Germany, or only for the US. And you mentioned the base profile, saying these are constraints on the core patient, or these are constraints on the Dutch patient, or what are you deriving from? What are you constraining? And the second part of a structure definition, well, that's actually the list of elements. Now you're actually walking into the structure you're describing. If you go to the FHIR spec, you will find all these renderings. You can see a nice tree with all the elements. Every element has a name. Something we call a cardinality. How many times is this element allowed to occur? Sometimes it's optional, sometimes you have a list. The data type, is this a string, is this a Boolean, an integer, or maybe complex? Is this a codable concept or you can define default or fixed values. You can add, for example, a length limit, saying my database name field is maximum of 100 characters, so you can limit that. You can add terminology bindings, very, very important in medical profiling. So add LOINC terms or ICD terms to a specific field. You can map an element to a different specification, and out of the box you get a lot of mappings for free. So out of the box, FHIR already has mappings to V2 and V3 and the RIM, but you can add your own if you like, even to legacy systems. And you even can add complex constraints using FHIR path, saying if that field is omitted, then you have to specify this value, or so constraints that overarch many fields using an expression language. Initially we used XPath to define these, well, complex constraints on an element, but XPath proved to be too limited for FHIR. We actually needed more than XPath could deliver, especially when you walk into stuff like slicing that became really hard to write in XPath, or even impossible, and you couldn't even read it. So that's why the FHIR community decided there was a need for a different query language. It wasn't a decision that was made lightly, because usually FHIR tries to leverage on existing technologies, but here it didn't fit. And also, XPath is tied to the XML format, but what do you do when someone sends you JSON? You convert it and then do the query and convert it back. It becomes weird. So we needed a query language that was on a conceptual level, that was not tied to a serialization format. And that's how FHIR path was introduced. And it's more readable. So you can see an example, say, well, patient.name where given is Wouter exists. So in the list of patient names, there has to be at least one record where the first name equals Wouter. This is like a link query in C#, for example. It's more expressive. And once these get longer, in XPath, you really can't see anymore what's the intent. Also, this allowed us to add some FHIR-specific keywords, like you can track a reference and stuff that's impossible in XPath. This is going normative and it's stable, and it's used quite extensively in FHIR now. And you can run validation based on FHIR path. So, how do you refer to a profile? Well, let's assume that this is some observation data that you're exchanging on the wire about a patient, a cholesterol diagnosis. FHIR allows you to put a tag on there, saying when you exchange that observation data, you put a claim, saying, I claim to conform to a specific cholesterol profile. Well, it's just a claim. Well, I can claim to be a woman. I can claim anything, but you have to verify, right? So what do? Well, a server can then resolve that URL. It uniquely identifies the profile, remember? And pull that profile from a database. And now it can actually verify that the message conforms to that claim, and if the claim is actually true. And if the claim is not true, then it can reject that instance. You don't have to put these tags on resources, but you can. That's an option. You can be very explicit about which profiles you conform. And you could add multiple tags, saying, I conform to a national profile, but also to an organization profile. So a little bit of versioning. Of course, this is very important. If you introduce a breaking change to a profile and people already implemented that interface, then disaster happens and people will die. So FHIR have very specific rules for that. You are allowed to make changes to a profile as long as it doesn't break compatibility. An example is just a typo in a comment. You know, you missed a couple of letters. You're allowed to change that. But you can't really change the cardinality of an element. People already implemented these servers, and it will break the existing code. So that's an incompatible change. FHIR says, as long as your fixes are compatible, and that's like fixing a typo or adding a comment, then you can maintain the canonical URL. It's still your contract. It's still the same. The meaning didn't change, and the contract still has the same ID. But once you make a breaking change, once you remove a constraint, add a constraint, or update a constraint in an incompatible way, then FHIR says you must assign a new canonical URL. Otherwise, you're breaking that contract. The mic is a little bit, am I touching it? Is it me or?
Yeah, I think, can you put it?
The plug?
Can you stop?
Gewoon een broekzak? Ja. Okay, do so. Okay. So again, if you introduce a breaking change, you must assign a new canonical URL. And you could just add a version number saying this is my first patient, and then next year I'm going to publish patient 2, or patient at a year or something, and then introduce some breaking changes. And then existing servers, they will still use the existing profile with the existing URL, and new implementation can start using that new profile, and slowly the old systems can migrate to the new one. You can even support both, and nothing breaks. So a published profile, once you put a profile up on the internet and say, hey, start building this, it's an eternal contract. And I guess my colleague Ewout always reminds me, we're not the police, so you can expect people to do this. They will break that, but fortunately we have something like validation, so you can verify. And if someone breaks that change, you can at least, well, compute it and detect it. Oh, I'm going to skip this. So how do you author profiles? Well, initially we didn't have any tooling 5 years ago, so we were forced to write these XMLs and or JSONs by hand. Well, pretty soon people tried to put it in a spreadsheet, because, well, that's what they had, and they needed to make the spec themselves, and the XML was just too hard, so, well, a spreadsheet, but it's really hard to map a tree onto a list. Actually, you can't, you know, it's just, so, it's not working. And there was actually then Excel was compiled into structure definition and it breaks all the time. You can do it. So fortunately, we have some tools. There's a company called Lantana. They've been active in Hl7 for a long time. They make an online tool called Trifolia, and I think it supports v3, v2, CDA, CCDA, and also FHIR. So different versions of Hl7 technology in this tool. Another tool is Mdhd. And they took a whole different approach. That's where you actually do the modeling in UML. The whole thing is expressed in UML, and from there, they generate V2, V3 FHIR profiles. Again, you have a mapping here. And then finally, Forge, that's a tool that I'm working on. And Forge is FHIR specific. So it doesn't support V2, it doesn't support V3, and it actually started out as kind of a reference tool to see if this technology we're inventing, if it actually works. So we created a tool that just 100% talks FHIR, just to see if we can create the profiles, and that slowly developed into a stable tool that's now, well, it's the popular FHIR profile editor. But if you're into UML in your company, take a look at Mdhd. And although if you do a lot of work with CDA and CCDA, then maybe Trifolia is the best choice for you. So you have options there. And maybe there are new tools in the future. So extensions. Well, often you need to add some elements. For example, in the United States, it's mandatory to administer race and ethnicity. In Europe, it's forbidden. So what do? We can't put that in the standard, because any which choice we would make, it would violate laws in a country. So you need extensions. Patient race and ethnicity. So in the United States, they take that core patient and they define a US patient profile, and then they add some extensions onto there, saying in the US patient profile, you have an extension for nationality and an extension for race, and they make that required. And in Holland, we don't have these extensions. It's my beard.
Really fake. Should be okay.
Well, we'll live. So how do you define an extension? Well, it's just a list of elements, maybe a simple element with a data type, or maybe a list of elements, a set of coordinates, or whatever with data types. So, well, that's a structure definition, right? It's a little structure that you can, like a data type. And an extension is actually a data type. Again, you can't exchange just a nationality. Nationality is always part of a patient, and you exchange that patient information. So an extension is a data type. Just as a profile, it has a unique identifier, a canonical URL. So you can publish copies of your extension definition all over the world, but they all have the same URI, the same canonical URL, so you know what we're talking about. And you can scope the context. For example, patient nationality, well, it doesn't make any sense to use that extension in a condition or an observation. So when you define an extension, you can say, well, this is designed to be used on that and that element, and you can have a couple. So nationality you could use on patient, person, practitioner, well, the human resources. Or you could define an extension on a data type, for example. FHIR even allows you to put extension on a primitive. So you could put an extension on string or boolean, but it becomes really weird. So that's strongly discouraged, but well, there's always use cases. How does it work putting an extension in a profile? It's actually interesting. If profiles are constraints, then how can adding an element be considered a constraint? Because I'm adding something. It doesn't seem right. Well, it's a little bit more subtle. You can consider profiling, it's somewhat the same as subclassing, object-oriented programming, where you derive from a class, but it's a little bit different. You're constraining here. So out of the box, FHIR says each element can have an unlimited number of extensions, and it's still a patient. And in your profile, you say, well, all these unlimited number of extensions are all fine with me, but I really need that patient nationality on the root. So you constrain the infinite list of infinite possibilities that are present out of the box. You constrain that and say, well, in all these infinite extensions that exist, I really need those two. And you can even reject all the other ones. Say, I don't understand all the rest, so just send me these two. So that's how adding extensions is still a constraint. So you can disallow an extension or require certain extensions. We could, for example, say in Holland that we disallow that race or nationality ethnicity element, because it's just illegal to exchange that information here. And if you ever receive some data on the wire and you recognize that element, you reject it, saying this is not valid. You know, this is probably for a different country. So you could do that. And then when the profile uses an extension, it actually points to that canonical URL. And that's how you see where you can find a definition of that element. So example, we have a patient, Irma, from Hl7 Holland. And on this patient record, there's an extension, nationality. That's not an out-of-the-box element. Well, that patient conforms to some profile. This is a Dutch patient, so Irma's records, they conform to the Dutch core patient. So we can look up that profile. And in that profile, we can find that it uses an extension. And that points to the canonical URL of the extension definition. So here you can see, extension with URI patient nationality. And now I go back to the database, and now I can find another structure definition, and this defines the actional element. So here it says, well, that's a code and a period, because you live in different countries for a while, so you move around. So it's a complex extension. And this extension could point to another extension, and you keep doing these lookups. And it's all driven by the canonical URL. So in the simplest case, you have a primitive extension. You can just define a string field like nationality, or I don't know, my birthday, it's a date, or some boolean saying, do I have brown hair, yes or no, whatever. But you can also have complex values. So patient birth time is an example of a primitive extension, or birthplace. These are standard extensions. They're part of the spec. They're not part of the core resources, but FHIR does provide a number of extensions out of the box, because in many places in the world we want to exchange information about the birthplace, so it makes sense to standardize the extension. It's not mandatory to use, but when you use it, we're all going to do it in the same way. But you can also have a complex extension. So maybe I want to do geographical coordinates, and I have an X and a Y, or a longitude and a latitude. That's 2 fields with 2 data types. So you can build a set of elements and define that in an extension. So this is a fairly new topic. I want to cramp in. We have some time. Packages. Traditionally, while we've been doing this, we're always exchanging a single profile at a time. But I mentioned these profiles, they form a graph, a connected graph. Because usually a profile mentions a lot of data types, and those data types walk into other data types. They might walk into other base profiles, and it's a connected graph. You have your terminology there. So usually that might be 60 different resources, and they're all pointing together. So it doesn't really make sense to send one of them. You need that whole set. And you're probably going to version that whole set, because you create these, well, conceptually related resources, you publish them so you can build that interface, and then 2 years from now, oh, the laws have changed and healthcare has changed, and you have some updates, you want to create a new version of that conceptually related set. So there is a form of dependency management here. And actually, so what you would need is a way of publishing sets of profiles and putting a version on there, and then referring to them in a structured way. Your profiles, your terminology, your operations, your examples, etc. So again, we didn't want to reinvent the wheel, so the community looked at existing standards, and well, many of the contributors, they were developers, so in our own IDEs, we have something like package managers. I have Mdhd in the .NET world, we have NPM coming from Node, and they make it really easy to pull in other people's libraries. So thinking about it, the problem is the same with profiles. Your profiles depend on profiles created by another organization. You want to point to them, but be very specific about the version that you're using. So when they publish a new one, nothing breaks. Well, that's package management. So we decided to reuse this existing standard. NPM is now used for versioning JavaScript code, but it doesn't say anything about the content. So now we're using NPM to exchange sets of FHIR profiles, and you could have a version on them. With one extra little added feature, this is something that only a FHIR server knows. You say, well, this profile has this specific canonical URL. Do you know in which package that is? And a normal NPM server won't be able to answer that question because it doesn't understand FHIR. It will be able to return to your package. You say, give me the package with that name and that version. But a FHIR server could also do this little lookup. Say, well, I'm looking for, I know, this special Dutch patient profile, and then the server comes back and say, oh, you need this Dutch patient package, or Dutch resource package. So you can have stacks of these. For example, I'm going to pull in some Dutch profiles, and they refer to some medication profiles created by Hl7, maybe Mdhd, and they go back to work that's done by Hl7 International. Usually, traditionally, right now, I have to gather all of this from different website. So I need to know that these are all my dependencies. First I have to go to Hl7, download some profiles. Then I need to go to Hl7 Holland, find whatever the profiles may be, I don't know, on their website. And then I have to go to this MedMy organization. And I don't know how that might be a zip, and that might be a bundle. And then I need to put it all in a folder in my hard drive. And it's laborious and it's error prone. And it's easy to just click on the wrong version. And so you really want to automate that. With a package manager, you just say, I need this, version 2, and it will solve everything for you. Because this will depend on version 3 of the NL medication, which will depend on version 1 of the NL core, which will depend on FHIR SU3. And the package manager will just get all these dependencies for you, and there will be no errors, because it's computable. So your version will be correct. Next sheet. So in our online registry, Simplifier.net, my colleague Martijn has been working on integrating some support for packages. So on Simplifier, you can start publishing your packages. It's still under development, but when you create a project, you can publish it, and it's immediately available. So you can start using that today. And that's an NPM package. You could use an existing NPM client, and it should be compatible, because it's the existing interface. It's not something new. And then just yesterday, I published a new force release. That's also a package client. So Simplifier is the server, that's where you publish your packages. And then Forge, you can consume them. So you can start profiling and say, well, I need a Mdhd profile. And you can just search in the registry. It'll grab the dependencies, resolve any child dependencies recursively, get everything it needs. And then about a second later, it has extracted everything in the folder, it scans it, creates an index of the canonical URLs, and you're ready to go. And you don't need to search all these websites. It happens out of the box. The same as in our IDEs. I just search for a little zip package, I get it. I don't need to download it by hand. So this is not a revolution, but it's a tremendous time saver, and it saves a lot of hassle, and it allows you to focus on the modeling instead of this tedious, laborious getting the right files together. A little bit of implementation guides. So you want to describe your interface. The profiles, well, that's just a bunch of XML, but the developer actually needs a bit of more. He needs a narrative to describe the use case, he needs the profiles, and he also needs some examples. So we can publish this in the implementation guide. So again, it's a set of conceptually related artifacts with some documentation. So whereas a package is more meant for systems, a package just contains computable artifacts. An implementation guide actually contains a story, a narrative for a developer to read. And if you do your job, then the implementation guide should be inviting to read, it should be complete, and it should allow a developer to build the interface without calling you, without talking to you, without ever meeting you. So try to think of some developer in a pit somewhere in a low-wage country, you know, he gets the job, has to be finished by tomorrow, and he should be able to succeed using your implementation guide. You can use the resource. Well, this is actually a little bit outdated. Just the difference between an implementation guide and a package. An IG is targeting humans, developers, contains formatted text, pictures, diagrams, explains how a developer should build it, and you publish it usually on a website or you want to share it with implementers. Whereas a package contains only machine-readable information, resources, XML, JSON, no narrative, no pictures, nothing. But a computer likes this. A computer can grab the package and understand the interface, and a human can grab the implementation guide and know how to build the interface. So that's the relation between the two. And usually your IG will point to a package. And this for the human, that's for the computer, and then you're good to go. So there are a couple of ways. We have the Ide Builder. That's an open source command line tool created by Hl7. It's powerful, but it's hard. It's a command line tool. It will just kick out on any exception saying file not found, so the burden's up to you. And it's kind of a build process. So you build your IG, and after 10 minutes, it generates a report, tell you if there are validation errors. You have to go back and run that tool a couple of times. But you can script that. So some of the FHIR implementation guides were created by this tool. And then we created an implementation guide editor in Simplifier, and that's more of an online environment where you can edit separate pages and then finally export it as HTML. So you have choices here in tools. I don't have a lot of time left. So finally, the key part, the registry. When we all start creating our own extensions, we don't have interoperability. If you have a birthplace extension, and you have a birthplace extension, and you have a birthplace extension, and you all assign a different canonical URL, well, we probably mean the same, but there's no way for a computer to know, so it's all incompatible. That wouldn't work. So yes, FHIR has profiling, but you're encouraged to first search for prior art. So before you start creating a profile or an extension, go to a registry and see if somebody else did that, if the Hl7 in your country affiliate already created that profile. Again, we're not the police, we can only make that simple. So what I'm relying here is developers are lazy. You know, you pay by the hour. If you have to finish tomorrow, you can find something that you can use, then, well, you're probably going to use it because, you know, you can go home quicker. So I'm counting here on the laziness of people. But we can't arrest them. You know, if all of you start creating the same extension, give it a different name, it is what it is. But this is crucial for the success of FHIR. If we can't have the community to get on board and publish their profiles in a registry, this will fail. So this is important. And we have a registry for profiles and also a registry for implementation guides. And this is for the official ones. You don't have to publish your implementation guide here, but if you have an official Hl7 standardized implementation guide, then you may want to put it up on that official Hl7 registry. So if you want to publish something in the registry, you can do it through Simplifier. You can create a free account here. And it contains profiles, affiliate profiles, but you can have private profiles. implementation guides, value sets, operation definitions, source parameters, examples, the whole shebang. So you can validate them. It can show you incoming and outgoing references, so which people are using my profile. That's very nice to know. Your download statistics. And it's a backend for Hl7 Registry. So, I'm going to skip this. Well, if you go here, this is an official Hl7 registry, and that's just a download-only site. And that is a limited set of profiles with kind of an official Hl7 stamp of approval. Hl7 doesn't check that, you decide, but if you want to publish something under the Hl7 flag, then you probably want to have, you want it to appear on the Hl7 registry. If you create profiles for your company or something, you don't want to put it up on Hl7, that's private or that's proprietary, and then you can just put it up on Simplifier. So this is all for the stuff that's standardized on an international or a national level. And everybody can publish here, that's not vetted, it's just a limited set. I'm going to skip this. So there's way more to tell, but we're out of time, so the rest has to wait until the afternoon session. We do have a Profile Academy on Simplifier. If you go to the homepage and scroll down, there's a little learning section, and that's where we have a couple of modelers in our company, and they do modeling, FHIR modeling work for clients, and they share their experiences. So this is not the theory, but this is actually modeling in practice. Often FHIR provides you with 5 different ways of doing something, and they talk about when to use what. So this is a very nice resource to use. There's no certification. And that's it. Let's grab some coffee, and hopefully I'll see you in the atrium in 5 minutes. Thank you.